Hello everyone, and welcome back to our series on effective vessel monitoring. In our last session, we covered the initial detection and identification of vessels. Today, we're diving into the critical second step, monitoring the closest point of approach, or CPA, and the time to closest point of approach, or TCPA. This is where we transition from simply knowing a vessel is there to actively assessing potential risks. Think of it as the heart of proactive collision avoidance. So, what are CPA and TCPA? Imagine two ships on the water. The CPA is the minimum distance that will ever exist between them if they both maintain their current course and speed. The TCPA is the amount of time until that closest point is reached. These two values, calculated continuously by our radar and ice systems, are our primary indicators of a developing close-quarters situation. A small CPA means the ships will pass very near each other, and a short TCPA means it's going to happen soon. Together, they give us a dynamic, real-time picture of the traffic situation. Now, just knowing these values isn't enough. We need a system to alert us when they cross a certain threshold of concern. This is where setting CPA and TCPA alarms becomes absolutely essential. These are not just bells and whistles, they are your automated safety nets. We must configure our systems to warn us when a situation requires our immediate attention, allowing us to focus on the most pressing risks in a busy traffic environment. Let's talk specifics. How do we set these alarms? Well, the exact values can depend on your specific area of operation, company policy, and the prevailing conditions. A common and effective starting point is to set a CPA alarm at 1 nautical mile and a TCPA alarm at 10 minutes. Why these numbers? A 1-mile CPA provides a significant buffer zone. It's close enough to be noteworthy but far enough to allow ample time for corrective action. It's a distance that, in most open or semi-restricted waters, you simply don't want another vessel to breach without a very good reason. The 10-minute TCPA alarm works in tandem with this. 10 minutes is a reasonable window of time. It's not so far in the future that the situation is truly hypothetical, but it's also not so close that you're forced into a last-minute panic maneuver. It gives the watch officer or VTS operator enough time to assess the situation calmly, communicate with the other vessel if necessary, and decide on a safe and efficient course of action. Think of it as your time to think alarm. When the 10-minute alarm sounds, it's a signal to start actively managing the encounter. Of course, these are just baseline settings. You must adapt them to your context. In a narrow channel or a dense traffic separation scheme, you might need to reduce your CPA alarm to half a mile, or even less, because close quarters passing is a normal part of the operation. Conversely, in wide open seas, you might extend it to 2 nautical miles to give yourself an even wider margin of safety. Similarly, if you're a very fast vessel or monitoring high-speed craft, a 10-minute TCPA might be too short. You might need 15 or 20 minutes to react effectively. The key is to establish a clear, well-reasoned policy for your vessel or control center and ensure everyone on watch understands the parameters and the reasoning behind them. Once your alarms are set, your primary task becomes monitoring the contacts that triggered them. When an alarm goes off, your attention should immediately shift to that specific interaction. The first step is to validate the information. Is this a real risk? Are both vessels' course and speed data accurate? Sometimes, a sudden, erratic turn by one vessel can trigger a momentary false alarm. A quick check of their track history will usually clarify this. But when the alarm is steady and the data is consistent, you need to start paying very close attention. The contacts that should worry you the most are those with a consistently low CPA value, say under half a mile, or those where the CPA and TCPA are decreasing rapidly. A rapidly shrinking TCPA is a huge red flag. It tells you that the geometry of the encounter is changing quickly and the window for action is closing. This is often called a rapidly developing situation, and it requires your full and undivided attention. Let's visualize this. On your screen, you see 2 targets. The system calculates a CPA of 0.8 nautical miles and a TCPA of 9 minutes. The alarm sounds. You now watch them. Over the next minute, you see the CPA holding steady, and the TCPA is now 8 minutes. This is a stable situation that needs monitoring. But consider another scenario. The alarm sounds with a CPA of 1.2 miles and a TCPA of 12 minutes. You watch for a minute, and now the CPA has dropped to 0.7 miles and the TCPA is 7 minutes. This is a much more dangerous situation. The vessels are converging faster than initially predicted, or one has altered course in a way that increases the risk. This is where your seamanship and experience come into play. You're not just a passive observer, you're an analyst. You need to look at the whole picture. What type of vessels are they? A large, deep draft tanker has very different maneuvering characteristics than a nimble fishing boat. Where are they located? A potential collision in an open sea is very different from one at the entrance to a busy port. Are there other vessels nearby that could complicate an avoidance maneuver? All of this context is vital. Your monitoring shouldn't just be about the numbers. It's about interpreting what those numbers mean in the real world. A contact with a low CPA that is on a parallel and slightly diverging course might be less of a concern than a vessel on a steady bearing with a larger, but decreasing, CPA. The first situation is stable, while the second is a classic constant bearing, decreasing range scenario, the textbook definition of a collision course. So, your workflow should be this. Alarms are set, an alarm sounds. You immediately identify the vessels involved. You assess the CPA and TCPA values and, crucially, their rate of change. You look at the vectors on your screen to understand the vessel's intentions. Is one turning? Is one speeding up? You then synthesize this data with your knowledge of the area, the rules of the row, and the vessel's characteristics. This complete analysis allows you to move from simply monitoring to making informed decisions. In our next video, we'll discuss that very topic. What to do once you've identified a genuine risk. We'll cover the decision-making process, communication strategies, and how to take or advise on effective action. It's the step that brings all this monitoring to its logical and safe conclusion. Thank you for joining me today. Mastering the monitoring of CPA and TCPA is a fundamental skill that turns a reactive watchkeeper into a proactive safety professional. Set your alarms, understand what they're telling you, and always be ready to analyze the developing situation. If you found this video helpful, please give it a thumbs up, and don't forget to subscribe and hit that notification bell so you won't miss the next part of our series. Stay safe out there, and I'll see you in the next video.